All right, so this is lesson 9. This is actually going to be the last lesson for pretty much all we're going to do for quadratics in this course. So tomorrow I'll give you a review and we'll figure out how to do the summative, right? So the goal of today is very similar to that of which we did with the optimization questions. So we're answering different questions with these, right? So as you kind of saw yesterday, we're answering questions about values along the independent axis, so the x-axis, as opposed to finding optimization values, which was dealing with the dependent variable y, right? So the goal today is going to be, can you develop quadratic expressions that represent real-world applications? And then from there, are you able to then solve the problems using one of your methods, right? So that's factoring or quadratic equation, right, in order to actually get the variable that you're looking for, right? You're also going to use your expansion process, one of your 3 methods, in order to actually come up with the quadratic expression that you're going to use the quadratic equation on, right? So that's pretty much it for today. We're going to figure this out. There's a couple questions, 3 questions here, and I'll give you a couple to practice, and you'll be good to go. So let's take a look at the first question. A building 15 meters by 24 meters is surrounded by a lawn of uniform width. Okay, that'll be the green section, the lawn. If the area of the lawn is 1/2 of the area of the building, find the width of the lawn. Okay, so it include a label diagram. So let's just start at the building. The building is the easy part, right? I got the dimensions of the building because it already told me. So I can go 15 multiplied by 24, okay? That's the area of the building, okay? Now, additionally, I have 2 things going on here. Now I can actually figure out the width of the green section as well, the length and width, right? By looking at the fact that all the way around the green section is uniform width. So it's the same variable. So if I were to say, we'll say this is specifically a little w, let little w represent okay. Okay, and then from there I can just go, okay, well, let's look vertically here for a sec. So the side lengths that are 15, right? These are 15 all the way around. Okay. So if we're looking vertically, then this width here from here to the edge is going to be what we said was little w, right? And then that's also the same down here in this side, right? Because it's the same the whole way around. And then horizontally, I also have a width, right? It's the same width as the black ones. Okay. Now, your job is to come up with the side lengths here that represent, we'll call this big length, and then we'll call this big width. Right? Sometimes they denote, the prof in university denote capital letters with little caps on them. Okay, so we need to figure out what those 2 side lengths are. So let's take a look at the thought process here. So I have the original 15 from the building, right? That's the still 15 from here to here. Okay, but then I also have these 2 other little widths on the end. So the side length is actually going to be 15 plus 2w, right? Then I have the same thing on the top, right? I have the original 24 from the building, and then 2w's on the end, right? That's coming from the red ones. Okay, now that's it for the diagram, right? Like that's all we've got going on. Now your job is to figure out some algebraic expression that we can apply the quadratic equation to solve for this little w. That's the whole question, right? At which point we'll be able to solve for what the dimensions of the grass are, right? So Let's just deal with the other part of this question here. Now we're done up to here, right? So I've dealt with the diagram, and now this question has provided me with something else. If the area of the lawn is 1/2 of the area of the building, find the width of the lawn. Okay, so let's just write out what they've said there. So let's say area lawn is equal to 1/2 area building. Okay, so then I can start plugging stuff in because I know what the area of the building is, right? The area of the building is just the area of the white section of this diagram, right? And so that's just 15 multiplied by 24, right? So that's going to be equal to 1/2 multiplied by 15 multiplied by 24. I'm going to move this over a little bit. Okay. Now on the left side, a little more complicated, right? So if I were to figure out what the area of, or our goal is to figure out what the area of the lawn is specifically, right? But if I were to take the dimensions that we found, right, this side length multiplied by this one, that would be the start of this question. Okay, so why don't we do that first? We'll say 15 plus 2w multiplied by 24 plus 2w, right? Now, that's the area of, let's pretend that that would be the area if the building was not there. That would tell me all of the grass. The problem is the building is there. And so what I need to do is actually subtract that white area off of the area of the big rectangle, right? So I'm going to subtract 15 times 24 because that's the white area. I'm going to get rid of the white area. And then the difference between the black and the green will give me my green border. Right? That's you. Now we're just going to do math on this. Like the problem's set up, right? So you're going to get an algebraic expression through expansion, and then you're going to use the quadratic equation to actually solve what W is, right? And that's going to be your answer, right? So let's just do the math on that now, right? This is just a math exercise now. No different than any of the questions that I've given you, right? So just solve for W or like expand these things. Like it's just a little more complicated, right? So there's just more stuff here. But that's the end of word problem, right? Now this is a math exercise. There's no more setup going on here, right? So we're just going to I'm just going to, for the simplicity of this question, I'm going to flip these two first brackets, which doesn't change anything. So I'm going to write 2w plus 15, and I'm going to go 2w plus 24. And then I'm going to write minus 15 minus 20, or multiplied by 24 is equal to 1/2. Okay. So now I can just do the math on this. Right. So I'm just going to use my expansion process in order to actually give me what it is I'm looking for, my algebraic expression. So let's deal with the top two first. I'll write that out. So 2w times 2w is going to be 4w squared. And 2w multiplied by 24 is going to be plus 48w. And then I'm going to do the bottom. Same thing. 15 multiplied by 2w. 15 multiplied by 24. Okay. So 15 multiplied by 2w is going to be plus 30w. And 15 times 24 is going to be plus 360. Okay, so that deals with this, right? That turns into those four terms there. Now you also have to subtract off. Remember, that just represented as if there was no building there. I have to subtract the building because there's no grass, obviously, on the building, unless it was on the roof or something, right? And in which case, this question would be interesting. So then you go, okay, well, minus 360, because this 15 times 24 is 360, right? And that's equal to 1/2 multiplied by 360. Okay, so I'm just going to clean this up now. So by collecting like terms, so I'm going to get 4w squared, 48 plus 30w. 48w plus 30w should be plus 78w, right? 360 minus 360 is going to be 0, right? Right? So these two 360s are going to cancel each other out, and you're going to be left with 1/2 of 360 on the right side, so 180. Right? And then I'm just going to bring the 180 over. 4w squared plus 78w minus 180 is equal to 0. There is your algebraic expression that takes care of develop algebraic expressions that represent real-world applications, right? And using the expansion process to get there, right? That's the first learning goal of today, right? The second learning goal is, now, okay, well, now what do I do, right? Is there something that I can do to this, right? So I would always want to, so remember what we're after. We're trying to solve for w, right, in the question, little w, right? Because little w represented the width of the lawn. So remember, if I were to try and solve this quadratic, as we say, right, we had two solving processes. We had factor, and then the second one was quadratic equation. And I remember, I don't really want to use quadratic equation because it's a little bit tedious, but always works. Right? But just tedious. So, is there something we could do to this? Let's try the factoring method first. Let's see what happens. Okay, so let's see if we can make this more simple, right? So your question is, can I turn this into a trinomial that looks a little bit nicer, right? So let's say, like in terms of being able to factor, right? So can I take a common factor out of here such that the trinomial gets easier, right? So my question would be, my initial question right off the bat is, can I make the value here 1 by taking a 4 out? Does 4 go into everything that you see here, all three pieces? I don't think it does. I don't think 4 goes into all three of those. So if it doesn't, you're limited. So then I would cut 4 in half and I take 2. I could see 2 could come out of there, right? But let's just check. 78 divided by 4 doesn't go in evenly. So this doesn't work. You're stuck, right? So instead of taking 4, let's take a 2. So if I take 2 out, then I'm going to be left with 2w squared plus 39w minus 90. That's going to equal 0. This looks a little bit better. That's your numbers. Your goal is to try and have to deal with something that isn't huge when we're dealing with multiplying, like your man method, trying to factor, sorry. All right, so I would have to find two numbers that would have to multiply to negative 180 and add to 39. Okay. We could take a minute and figure this out, or you could type this into Desmos or Wolfram Alpha, and you could probably find out pretty quickly that this is probably not factorable. 39 is kind of an odd number to get to, right? But so you would just go through your process of checking to see if this is factorable, because I'd prefer to do that than quadratic equation. So 180 divided by, we'll just start at 3, because we're probably going to get two numbers that are pretty close. So that 60 and 3 multiply to 180, or negative 180, but that's not going to add to 39. So start again. 180 divided by 4 is 45. That's getting closer, right? But still not going to add to 39. Because if I made 45 negative, that's not going to work, right? So 45 and 4, right? If I made this negative, that's still going to be 41. That's not going to work. So those don't work. Let's go to the next one. 180 divided by 5. That's 36. Not going to work. Not going to add the 39. 180 divided by 6. So 30 and 6, also not going to work. 7 doesn't go in evenly. 8 is going to be 10, so that's not going to work. Not going to work. So that means this is not factorable. So that means this is off the table now. You're forced to use the quadratic equation. Okay. So that's not bad. We'll do it quickly here, right? W is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a, right? And you're just going to plug in the variables that you see, or the coefficients, right? So I'm just going to plug in, okay, negative 39 plus or minus the square root of 39 squared, right? Minus 4 multiplied by 2 multiplied by negative 90. Okay. Move this down, and then all of that's divided by 2 times 2. Give ourselves a little bit of space. Okay. And then we'll just do the math on that. So we're just going to go, okay, well, W negative 39 plus or minus, turns out the inside works out to be the square root of 2241. And that's all divided by 4. Right? And then again, if you do the math on that again, you're going to get two values of W, one of which is 2.08, and the other will be negative 21.6. Now, your job is to obviously all interpret. This question isn't quite over. There are your two answers, right, for the width. But your job is to interpret the answers, right, that you get out from the quadratic equation. And remember, you always get two answers from the quadratic equation. Sometimes they don't make any sense in the context of the question, right? So in the context of this question, it does not make sense for either of these two W's to be negative, right? They're widths. They can't have negative width. Therefore, this is useless to you. It's a width that satisfies mathematically, but in practicality, it doesn't make any sense, right? And so this, I'll do this in green because this represents the grass. The width is 2.08, right? We'll say it's meters. Yeah. Right? There you go. So all the way around the building, you've got 2.08 meters of grass, right? Which is nice to know. Like, it's tough to tell from here how big, or like, if you were to try, if we were doing schematics or something for a building or a new plot, right? Like, even if this was your house all the way around or something, right? Like, you would probably want to know before you bought it or before they built, just have some sort of idea as to how much grass is going to be there. So do you need a riding lawnmower versus do you need just a regular lawnmower, right? A push mower, right? So you kind of want to be able to, like, I'd have no idea, right? Visually, like, how much grass is going to be there. Like, I have no idea, right? So at least this way, you get to make some form of informed decision, right? Well, I know that there's going to be 2.08 meters of grass everywhere around this picture, right? Or around around my house, I'm going to have 2.08 meters of grass, right? At which point you're like, okay, well, I could probably get away with just a push more, right? Which is probably going to be the case anyway, but at least you know how much grass you're going to have to cut and like how long that's going to take, right? So that's good, right? The whole point of this is being able to make informed decisions about things. Using quadratics is the important part. Okay, so that's question 1. We'll take a break here, and then we'll do